Today we're going to be talking about forces and motion. Position is a place or an object's location. Examples of position include a classmate sitting next to you is about a meter to your right. A mailbox is 2 blocks south of where you live. So you are describing where something is located using position. Each time you identify the position of an object, you are comparing the location of the object with the location of another object or place. A reference point is a location to which another location is compared. So let's say you're going to Walgreens. You need to get to Walgreens, but let's say you're getting directions from someone and they're trying to tell you how to get to Walgreens. Well, more than likely they're going to talk about other landmarks or reference points to give you an idea of where Walgreens is located. They could say that it's in front of the gas station or beside Food Lion. So that way you know the general area that Walgreens is located. That is considered a reference point. Motion is a change of position over time. A change in position is evidence that motion has happened, that has taken place. Speed is a measure of how fast something moves through a particular distance over a definite time period. Distance divided by time is the equation for speed in order to calculate it. The greater the speed an object has, the faster it changes position. The three equations that you see here are for speed, but it all depends on what factor of speed you're trying to calculate for. It could be speed, it could be distance, or it could be time. And as you can see, you've got the one standard equation, but it's been rearranged a few times to show you how you could find distance and time. Speed is equal to distance divided by time. If you're trying to solve for distance, you would take speed and multiply it by time to get the distance. If you're trying to solve for time, then you would take the distance divided by speed. The units for speed in the metric system would be meters per second. That's how it's usually addressed. It could be kilometers per hour. And if you're talking in the U.S. customary units, if we're dealing with that, then more than likely it's going to be miles per hour or mph. 1 miles per hour is equivalent to 0.45 meters per second. Distance and time graphs. The time is always going to be represented on the horizontal axis, which is known as the x-axis. And the distance is always going to be vertical and represented on the y-axis. As you can see, you have 3 different lines, one green, one red, and one blue. Well, each one of these lines, depending on the slope of the line, is telling you whether or not an object is getting faster, if it's got a steady speed, if it's constant, if it's slowing down, or if it's stopped. As you can see, the green line has a steeper slope, so that means it's getting faster over a smaller time period and it's covering more distance. The blue line, as you can see, over time, it's getting faster, but it's more of a gradual time period. It's not over a few seconds or a few minutes. It's more gradual. Then the red line, the object increases in speed, and then it stops. That's what stationary means. It's stopped over a certain time period, and then it starts to come back to where it began. The distance closes back into zero, so it's coming back. That car or whatever that object may be is coming back to where it started. And this is another example of a distance and time graph. So look at the lines and try and figure out, according to your notes packet, which line means what. And we'll cover this in class. We're going to be working several examples of distance and time graphs after you guys complete your notes packet. A vector is a quantity that has both size and direction. Examples of vectors include velocity, acceleration, force, and momentum. The length of the arrow indicates the amount or size of the force. So a vector, if it's got a small arrow, then that means it only requires a small amount of force. If it's got a longer arrow, then what do you think it means? If you said more force, then you're correct. Velocity is a speed in a specific direction. So not only are you going to tell a person as far as how fast something is going, but you've got to tell them the direction. Directions can be north, south, east, west. It could be to the right or to the left. But you've got to be able to identify how fast the object is traveling and in what direction the object is traveling in. That is velocity, because velocity is a vector. It has both magnitude and direction. Acceleration is the rate at which velocity changes over time. If velocity does not change at all, then no acceleration takes place. Acceleration in the same direction as the motion is occurring. That means that speed is increasing and it has positive acceleration. Acceleration in the opposite direction of motion means that the speed is decreasing and it has a negative acceleration. Acceleration at a right angle to motion means that the direction changes, but the speed has not changed. This is the equation for acceleration. Vf stands for final velocity, Vi stands for initial velocity, and t stands for time. So what you would do is take the final velocity that the object stopped at minus the initial velocity that that object started at. You would take those two, subtract them, and then you would take that and divide it by the time it traveled. The standard units for acceleration are meters per second squared, or meters per second per second. Velocity time graphs displays acceleration. Time, again, is on the horizontal axis, or the x-axis. Velocity is on the vertical axis, which is the y-axis. This is a diagram or a graph to show you an example of what each line means on a velocity graph. The first blue line you see that's going up steadily at a constant rate is meaning that it is accelerating, it's gaining speed. Then the red line that says steady speed means it has leveled off, it's traveling at the same speed over a period of time. It does not mean that it has stopped. It means that it has a steady speed. It might be traveling, in this case, it's traveling 20 meters per second between 20 and 40 seconds. The green line means that it is decelerating, means it's slowing down. Because it was traveling at 20 meters per second, and now it is traveling at 10 meters per second over a distance of, or over a time period of 10 seconds. Then, as you can see, the blue line toward the end at 50 seconds all the way up to 90 seconds, the speed is increasing. The acceleration is increasing. And this is another velocity and time graph. So use your notes and try to figure out what each line represents, what type of acceleration. So take a minute to figure that out and jot it down on your paper. We will go over this to be sure that you are correct.